This is an AQA GCSE coordinated science chemistry question. I'm going to recommend you try each section, pausing as you go, and then review your answers. So here is part A, part B and C, and finally part D. So as you can see, this is an 8-mark question. So going back to part A, you can see here hydrogen reacting with oxygen to make water, and we're provided with the energy profile diagram. Your job here is to label the activation energy. Now you've got to remember that we have got the reactants have a certain amount of energy. We can see it's around 800 kilojoules there, and the products have around 300 kilojoules. So the overall change there, well, we're actually going to see later in the question, but it's not as straightforward as simply going from A to B. We need to provide energy to initiate the reaction. That's the activation energy, and that's represented by the big hump. It's like getting over a high jump. So the activation energy is going to be where I have put the arrow here. And you can see I've taken it from level with the reactant line all the way up to the top of the hump. And it's really important that you do that. I've not written down that that's the activation energy here, but you should be labeling that as well. Actually, I've just added it there now so you can see it is clearly labeled. Moving on to part B, and we have got here the overall enthalpy change. Now, I've already spoken about this in the previous question, but to work out the energy change, you need to look at how much energy the reactants have and how much energy the products have. So I've brought the graph over and I've extended the lines across. You can see that the reactants have 800 kilojoules, the product 300 kilojoules. So the overall change is the difference between the two, and that's 500. Moving on to part C, oxygen is in group 6 of the periodic table, and figure 2 shows the outer energy levels in one molecule of oxygen, O2. Draw the electrons in the outer energy level. So the first thing to remember here is that if oxygen is group 6, it has 6 electrons in its outer shell. That means to get a full outer shell of 8, it needs to gain 2. It does that by sharing. So if it gains an electron by sharing, it puts one in itself. So I need 2 pairs of shared electrons to bring them up, and I've put those into the middle. So 4 electrons, 2 from each oxygen, and that's representing a double bond. But I've then got to look at how many each oxygen has left. And if oxygen has 6 electrons in the outer shell and 2 have been used, that means we've got 4. So I have those, as you can see here. Moving on to part D, and we've got an a bond energy calculation. So these are fairly common within the exam. You do need to be prepared. You'll be given values, but you have got to work out which bonds are breaking and which bonds are forming. So you're always going to break every single bond in the reactants. That's the assumption that we make. And on here, because I've got 2 HOOH molecules, that means in one hydrogen peroxide, I've got 2 OHs, but I've got 2 hydrogen peroxides, so I have 4 OHs. So that's 4 times 463. Now you'll notice I've put a plus sign here as well. That's because breaking bonds is endothermic, and endothermic is positive. Going to do the same again with the oxygen. I'm breaking 2 O single bond O bonds, and they are 138 kilojoules per mole. Also positive because I'm breaking the bond. In total, that means that we have got 2,128 kilojoules, and that's a positive value. But then I'm going to form the new bonds in the products, and I'm going to make 4 OH bonds. So that's 4, each with a bond energy of 463, but because I'm forming the bond, it's negative. So it's 4 times negative 463. And I'm making 1 single O double bond O bond. So that's a negative 496. When I add them together, it comes to negative 2348. To work out the overall energy change, you add those two numbers together, the positive and the negative. And when you do that, that takes you to a value of negative 220. That takes you to the end of this question. Thank you for listening.